Hello, welcome back to the Knowledge Catalog Green and Chemistry. This is Chemistry 12. So for this session, we will be having um, a thorough discussion, or actually this is a session intended for the learning competency number 9, which is using the mole concept to express masses of substances. So if you may need to follow through with the learner's module, you can open them in Unit 2, Module 4, pages 64 to 67. This one is divided into 3: pre-assessment, multiple choices, and then a discussion on the Avogadro's number, and then a practice for solving problems using Avogadro's number. Okay, so let's begin with the pre-assessment. You will need to get your notebook or a clean sheet of paper for this, and then label it pre-assessment, multiple choices. Question number 1. Suppose you were asked to prepare a 250-gram chocolate mousse, which is 35% chocolate, 30% cream, and 20% milk, 10% sugar, and 5% butter. How much cream are you going to use? So A, 75 grams of cream, B, 60 grams of cream, or C, 73 grams of cream, and then D, 62 grams of cream. Pause this video if you need more time. Okay, if you have decided to continue, let us proceed with question number 2. Cheska measured the mass of 10 pieces of each of the following materials: marble, pebble, and a ball pen cap. What will be her findings based on the data she obtained? So for marble, it's 50 grams, for pebble, it's 35 grams, and then for ball pen cap, it is 20 grams. So letter A, different materials have different masses. Letter B, materials of different kinds differ in amount, color, and texture. C, the same number of materials has different colors and appearance. And then D, the same number of materials of different kinds has different masses. Pause this video if you need more time. If you have decided to continue, let us proceed with question number 3. The following are representative particles of matter. Which among them represents a covalent compound? A, atom, B, ion, C, molecule, or D, particle unit. Pause this video if you need more time. If you have decided to continue, let us proceed with question number 4. A bag of NPK fertilizer marked 1648 contains 16% nitrogen, 4% phosphorus, and 8% potassium. The other 27% is usually inert filler material such as clay pellets or granular limestone. What is the mass of nitrogen present in a 500-gram pack of NPK fertilizer? A, 80 grams, B, 40 grams, C, 20 grams, or D, 10 grams. Pause this video if you need to compute for it, and thus you need more time. If you have decided to continue, that means you are ready for question number 5. How many particles are equal to 1 mole? A, 6.02 times 10 raised to the 22nd power particles, B, 6.02 times 10 raised to the 23rd power particles, or C, 6.02 times 10 raised to the 24th power particles, and D, 6.02 times 10 raised to the 25th power particles. Question number 6. How can the knowledge about mole be used by environmentalists? A, mole concept can be used in environmental monitoring. B, it gives information on the most dangerous pollutants in the atmosphere. C, it gives a feedback on the kinds of pollutants present in the atmosphere. D, mole concept can be used in quantifying the amount of pollutant particles released in the atmosphere. If you need more time, you can pause this video. If you have decided to continue, that means you are ready for question number 7. How can you apply knowledge on percentage composition? A, in maintaining the quality of food product. B, in checking the amount of sugar present in the soft drink. C, in identifying the correct amount of substance present in the sample. D. All of the above. Pause this video if you need more time. If you have decided to continue, let us proceed with question number 8. How many percent of hydrogen is present in water or H2O? A. 12%, B. 13%, C. 11%, or D. 10%. For this, you may at least round it up to the nearest ones. Pause this video if you need more time. If you have decided to continue, let us proceed with question number 9. Which of the following units is used in expressing the amount of substance in terms of the number of particles? A. Liter, B. Gram, C. Mole, or D. Celsius. Pause this video if you need more time. If you have decided to continue, let us proceed with question number 10, the last item. What do you expect to observe in a mole exhibit of different substances? A. Different kinds of elements, B. Different colors of substances, C. Showcase of one mole of different elements having different masses, and D. Showcase of one mole of different substances having the same masses. Pause this video if you need more time. If you have decided to continue, let us proceed with the answers. Okay, let's begin with question number 1. The answer is A. 75 grams cream. The answer to question number 2 is B. The same number of materials. So all of them are 10 pieces of different kinds. So may marble, may pebble, and bulb and cap. They have different masses. So 50, 35, and 20. Those are our readings for the masses of these materials. Question number 3. The answer is molecule. So if it's a covalent compound, it's a molecule. If it's an element, that's an atom. If it's an ionic compound, you can actually use formula unit or ion. Question number 4. The answer is A. 80 grams. The answer to question number 5 is B. 6.02 times 10 raised to the 23rd power particles. 6.02 times 10 raised to the 23rd power is Avogadro's number, and we will be discussing it in this session. The answer to question number 6 is B. The mole concept can be used in quantifying the amount of pollutant particles released into the atmosphere. The answer to question number 7 is D. All of the above. The answer to question number 8 is 11%. I think you got 11.11. The answer to question number 9 is C. Mole. The answer to the last item is C. Showcase of one mole of different elements having different masses. So yeah, you can report your score as 10 over 10, and I'm hoping that whatever score you got, you understand that this is an assessment that intends to know what so far do you know. Okay, so we're done with the first part. Let us now proceed with the second part. Avogadro's number as a discussion. So Avogadro's number basically discusses the following. So before the text, we start with this one. So it says Avogadro's number is this one, 6.02 times 10 raised to the 23rd power. I'm sorry, it is not a subscript. It's supposed to be a superscript. Okay, so again, 23 is supposed to be superscript. So dapat nasa taas siya. And so 1 mole of a covalent compound has 6.02 times 10 raised to the 23rd power molecules. Kaya magkatapat sila. And 1 mole of an ionic compound has 6.02 times 10 raised to the 23rd power formula units. And then 1 mole of any given element has 6.02 times 10 raised to the 23rd power atoms. So there's this number of atoms comprising an element so that it's considered to be 1 mole. Okay, so say for instance, parang 1 pack of an element has 6.02 times 10 raised to the 23rd power atoms of that element. So, ganun siya. So, a mole or a mole of a substance is 6.02 times 10 raised to the 23rd power representative particles of that substance. So, the representative particles can be atoms for elements, molecules for covalent compounds, or formula units for ionic compounds. And so 1 mole of carbon-12 has 6.02 times 10 raised to the 23rd power atoms because carbon-12 is an element. Kaya atoms yung ginamit natin dyan. 1 mole of water naman, which is a covalent compound, contains 6.02 times 10 raised to the 23rd power water molecules. Kaya molecules because it's a covalent compound. You heard the dog, I know. And 1 mole of sodium chloride, which is an ionic compound, it's common salt, table salt, contains 6.02 times 10 raised to the 23rd power formula units of sodium chloride because sodium chloride is an ionic compound. So, depending on what kind of compound you're referring to will be the kind of units you will be using. But the number will be the same. It's going to be 6.02 times 10 raised to the 23rd power. So, let's have the following sample problem. Suppose we're going to look for the number of molecules that are in 4 moles of carbon dioxide. So what we'll be doing here is if you have 4 pieces of carbon dioxide, how many molecules of carbon dioxide makes up those 4 pieces? Molecules kasi is different from the from the moles. Okay, so we'll be turning we'll be turning 4.0 moles into 0.4 times 10 raised to the first power because this problem solving, the procedure of this problem solving exercise is using scientific notation. Okay, so the givens in this problem are the following. So 4 moles of carbon dioxide, and what we're going to do is we'll be looking for the number of molecules. One more given is that we remember 1 mole of a covalent compound such as carbon dioxide is equal to 6.022 times 10 raised to the 23rd power molecules of carbon dioxide. Okay, so it's a covalent compound, kaya molecules yung nandito. Pero if this is an element, we'll be putting atoms of that element. If this one is an ionic compound, we'll be putting formula units of that ionic compound. Ayun siya. Okay, so for the solution, we begin by writing the given 0.4 times 10 raised to the first power moles of carbon dioxide. What we'll be doing is we consider this as a whole number, so this is over 1, and we will be multiplying that with 6.022 times 10 raised to the 23rd power molecules of carbon dioxide. Okay, you remember, this is taken from this table of equivalence. Since what we're looking for is molecules of carbon dioxide, ito yung hinahanap natin, dapat siya yung nasa taas. Kasi ito, i-cancel out niya dapat yung nasa baba, which is 1 mole of carbon dioxide. Okay, so if you have 0.4 times 10 raised to the first power moles of carbon dioxide, if you have that, okay, you do not know how many molecules it has. But you know that if you have 1 mole of carbon dioxide, it has 6.022 times 10 raised to the 23rd power molecules of carbon dioxide. That is what you know. This is the table of equivalence that you know, but not the 0.4 times 10. Okay, this is what you know, 1 mole. You do not know 4 moles. Okay, I hope that is clear. Okay, so now what you'll be doing is you'll be canceling these out because when you multiply these numbers, you will be getting the final absolute value, but the units are going to cancel each other out. Then when there's a need for it, okay, so this 1 moles of carbon dioxide will be put in the numerator. This mole of carbon dioxide will stay as a denominator, and since they are the same, we'll be canceling them out. Ayan. Okay, so the correct answer is going to be 2.41 times 10 raised to the 24th power molecules of carbon dioxide. So you basically multiply 0.4 with 6.022, you'll be getting the absolute, the base number. And then when you multiply numbers in scientific notation, you just add up the values of their powers, of the exponents, you just add them up. So you'll be getting 23 plus 1, that's 24. Okay, so the answer is 2.41 times 10 raised to the 24th power molecules of carbon dioxide for every 4 moles of carbon dioxide. As promised, the last part will be a practice problem. More practice problems. I'll be giving you 4 more problems. But for sample problem number 2, we will be using something almost imaginable. Okay, so first sample problem under the practice. How many pieces of manga seeds are equal to 3.50 moles of manga seeds? So 3.50 moles is 0.350 times 10 raised to the first power moles of manga seeds. So what we know is, for every 1 mole of manga seeds, there are 6.022 times 10 raised to the 23rd power pieces of manga seeds. Mayroong ganito karaming piraso ng munggo kada isang mole ng munggo seeds. Okay? So I hope that is clear. So for the solution, ang lalagyan natin dyan as the first part is which one? Okay, dapat yung given na value na to, itong 0.350 times 10 raised to the first power moles of what? Of manga seeds. And so it's found as a numerator, and then as usual, the denominator is 1. We'll be multiplying it with this table of equivalence. Kaso, ang una nating isipin dyan is alin yung nasa taas, alin yung nasa baba. I remember, since nandito sa taas itong moles of manga seeds, kailangan natin siya ma-cancel out. So, paano maka-cancel out yan? Okay, by putting a mole of manga seeds from this table of equivalence sa ilalim. Anong lalagyan natin sa taas as a numerator? Yeah, it's 6.022 times 10 raised to the 23rd power pieces of manga seeds. Siya yung nasa taas kasi siya dapat yung final answer natin. Siya yung hinahanap natin. At ito, i-cancel out siya. So, what you'll be getting is, you'll be canceling them out. You just multiply 0.35 with 6.022 to get the absolute value, and then you just add up the exponent of these two since, ayan. Nagkataon kasi na positive yung mga exponents nila. So, 24 lagi naging result niyan. And the absolute value is 2.11 pieces of manga seeds. So, again, multiply these absolute values, these base numbers first, and then add their exponents up. Okay, so ibig sabihin yan, kung halimbawa, meron ka lang isang mole ng manga seeds, ang mayroon doon na piraso is 6.022 times 10 raised to the 23rd power pieces of manga seeds. Pero since meron kang 3.50 moles, okay, 3.50 moles, dapat meron ka ng 2.11 times 10 raised to the 24th power pieces na ng manga seeds. Nagbago na. Okay? Sample problem number 3. So instead of mango, okay, instead of looking for the pieces, for the atoms, for the molecules, for the formula units, we'll be looking now for the number of moles. So ilang moles ang mayroon, moles of rice grains ang mayroon, so 1.807 times 10 raised to the 24th power grains of rice. So, kung meron kang ganito karaming grains ng rice, ilang moles kaya yan? Yan. So, the given is that for every 1 mole of rice, merong 6.022 times 10 raised to the 23rd power grains of rice. Okay, so now what they're going to do is, of course, you write the given. You write the given. Since this is already in scientific notation, you don't have to convert it anymore. Okay, so you just write it like that, and remember it's a whole number, so it's over 1. And then you multiply that with this table of equivalence. Kaso, which one will be put sa may taas? Of course, the unit you're looking for. And what unit are you looking for? You're looking for the moles of rice grains. Okay, that's what you're looking for. Because you already know the grains, the number of grains. Ito siya. What you need to know is the number of moles. So, you know the number of grains. What do you do now? You put that as the bottom, and then nasa taas is yung unknown. So, 1 mole of rice is mole of rice is the unknown. Okay, and what you put sa ilalim is yung known value. Yung known na unit, okay, which is grains of rice. You need to do this. You need to remember doing this because you would like to cancel out these units. And if you do so, if you could cancel them out, that means you are on the right track. So what you need to do is cancel out grains rice and then multiply 1.807 times 10 raised to the 24th power with 1. So basically it's the same number. And then you divide that by 6.022 times 10 raised to the 23rd power. So what you do here is you multiply, you divide these absolute values, and then you subtract these exponents. So you'll be getting 3.02002 moles of rice. Ayan. So, ibig sabihin, okay, if you have 1 mole of rice, meron lang siyang 6.022 times 10 raised to the 23rd power grains of rice. Okay? But if you have 1.807 times 10 raised to the 24th power grains of rice, that is equivalent to 3.022 moles of rice. Gano'n karami yung grains of rice sa isang mole? Ito. Gano'n naman karami ang grains of rice sa 3.002 ng moles? Ito. Okay, so next is sample problem number 4. So now we go back to the elements. Sorry. So how many atoms are there in 16 moles? So that's 1.6 times 10 raised to the first power moles of sodium. Ilan naman kayang atoms na mayroon sa 16 moles of sodium? So remember that for every 1 mole of sodium, meron kang 6.022 times 10 raised to the 23rd power atoms of sodium. So pare-parehong number lang, no? Pare-pareho lang yung table of equivalence. Amazing na. Okay, so for the solution, ilalagay mo syempre yung given mo una. Ayan. So siya yung nasa taas, tapos ginamit natin scientific notation kasi you need to express your answers in scientific notation. And also the solution has to be expressed in scientific notation. I don't want you to count many zeros. Okay, so just use it. Remember 1.6 times 10 raised to the first power moles of sodium is over 1. It's a whole number. And you multiply that with this table of equivalence. So moles of sodium is found in this in here, in this fraction, it's found as a numerator. So if you would like to cancel out moles of sodium, you have to put it in the next fraction as a denominator. And yung nasa taas is yung desired value, which is the atoms, the number of atoms for sodium. Okay, so you put 6.022 times 10 raised to the 23rd power atoms of sodium, and you divide that by 1 mole. So basically, it's just that you multiply 1.06 with 6.022, and then their exponents are to be added. Okay, so you just cancel these out, and you will be getting the following answer. 9.64 times 10 raised to the 24th power atoms of sodium. Okay, so if you have 1 mole of sodium, that is equivalent to 6.022 times 10 raised to the 23rd power atoms of sodium. But if you have 16 moles of sodium, that is equivalent to 9.64 times 10 raised to the 24th power atoms of sodium. I hope I'm still making sense. Okay, so the last sample problem is the following. How many moles of sodium chloride? Sodium chloride is a combination of sodium and chlorine, and what they're producing here is an ionic bond. So how many moles of sodium chloride will there be in 7.67 times 10 raised to the 23rd power formula units of sodium chloride? Remember, formula units is the unit we'll be using for ionic bonds, for ionic compounds. So the givens are the following. So for every 1 mole of sodium chloride, as usual, it has 6.022 times 10 raised to the 23rd power formula units of sodium chloride. That is the relationship always. And then for the solution, you write first the given number. So it's 7.67 times 10 raised to the 30th power formula units of sodium chloride. And you are going to divide that by 1 because, again, it's a whole number we're talking about. Okay, and multiply that with the table of equivalence. So for the table of equivalence, you have this right here. So what you need to remember again is to make sure that formula units sodium chloride is cancelled. How do you do that? How do you make sure of that? You put the same, the factor, the side of this equation You put the side of the equation that is similar to this unit as the denominator so that it will be cancelled later on. So what you put above is 1 mole of sodium chloride, and beneath that is 6.022 times 10 raised to the 23rd power 4 milliunits of sodium chloride, so that they will get to be cancelled out. Okay, so next is you just divide 7.67 by 6.022, and then you are going to subtract 23 from 30. So you'll be getting the following answer. It's 1.27 times 10 raised to the 7th power moles of sodium chloride. Ayun. So I hope that you got the answers correctly. I mean, for the fourth, at least for the fourth and fifth examples. Okay, so in this session, you were done doing the pre-assessment. Actually, yeah, mali yung pagkakatagline nakalagay sa summative assessment. So that was a pre-assessment, 10 items, multiple choices. The second part is a discussion on Avogadro's number. And the last part is a practice on solving problems using Avogadro's number. And so this is still Sir CJ, and I hope that I'll be seeing you in the next video in this series. Thank you for visiting the Knowledge Catalog. See you.